Okay, what on earth does all of that mean? Well, it was all rather technical in terms of finding models, but now let's actually look at how good are the model predictions. And we're going to do that with a scatter plot, showing the predicted values on the x-axis and the observed values on the y-axis. We're going to create a data set to facilitate this plotting. We'll create a data frame, a new data frame that contains the predictions from DT11 using DT11 predict. We predict DT12. Oh, actually, I think it's DT. Let's do it with DT10. That's the very best model, and then we'll do it with DT11, which was with weight removed. So we do DT11 there. We've got to get that. Okay. Please make a variable in the data frame, call it DT10, and fill it with the values of predict the model DT10, and the same for DT11. Let's run that. Appears to have worked. If we look at it here, it is P1, and there it is. It contains two variables, DT10 and DT11, as we named them here, and 243 observations, which is correct. Now we will create a new DD and bind together the columns of DD and P1. So now we have DD1. This is a data set. It's the original data set, but with two new variables. And they're the two predictions. Predictions of model DT10 and predictions of model DT11. That just facilitates making the graph like this. Do a ggplot. Use the data in DD1. Please put on the x-axis DT10. That's the predictions of model DT10. And on the y-axis, please put the original data, the kind of correct values, the observed values. And we'll make a scatter plot with points. Here we go. So this is the predicted values from the model against the observed values. What we can note here is for model DT10, that's just with abdomen and weight, and for a predicted body fat of 20%, the observed varies between about 15% and maybe nearly up to 30%, somewhere between 25 and 30%. So it's about 5 units of variation around the prediction, maybe a little bit more than that. What we can now do is copy this, do the graph again, but for a model that we know is significantly worse. I shouldn't use the term significant there, but that you might think about p-values, but it's not about p-values at all. A model that is definitely not as good at predicting as is DT11. It doesn't contain weight. It had a big increase in AIC. So let's see what that does. Now if you look at this 20 units, 20% body fat, it goes from about 10 maybe up to, well, that could be around here. So the predictions, for a prediction of 20, there's actually a bigger spread of observed values. That means the model is not doing as good a job as predicting. So we can visualize here how well the model is predicting. I mean, what does this mean in terms of the usefulness of the predictions? Well, if we accept that plus or minus 5% variation in body fat is okay for the purposes that we're using the predictions, then model DT10 is just fine. If plus or minus 5% is not okay, then we're going to have to think about measuring some other variables actually, because we won't do much better with if we add other variables. We can see that because it's only 3 AIC units as different. So just generally, very generally speaking, making a graph like this is very, very useful and very important after we go through all that technical stuff with drop terms and step AIC and dredge and so on. It's really good idea just to get grounded again in the data by making a graph of predicted against observed like this and understanding the variation. And also doing the model diagnostics might help see where there could be problems in the model that could be introduced, because we've only been doing variable selection in order to improve prediction. There are other things that we might be able to do to improve predictions. Good, so that is about it. Let's make it so you can see me again. That's about it then. You can see that we can select variables in order to get a better AIC. AIC is a measure that should increase the predictive power of the model. And then we could go and use the model and test it with some new data. That would be another test of the predictive power of the model. Just to emphasize, we have not been doing anything to try and get an understanding of what causes variation in percent body fat, or what explains variation in percent body fat. Good. That's all for this before class material. I look forward to seeing you in the practical and helping you go through some more examples of model selection. Thanks very much and see you soon.